Volcanic eruptions of molten rock from within the Earth are awesome demonstrations of the pent-up heat energy stored within our planet. The world is dotted with volcanoes and their rock products, both ancient and modern reminders of the Earth's long history of volcanism. The variety of materials volcanoes produce, their styles of eruption, and the edifices they create all reflect the geological environments within which they develop. Active volcanoes are found on land and, above all, in the deep sea, and their distribution, which is far from random, reflects the continuing dynamism of the planet. Volcanism is the process by which magma, molten rock from inside the Earth, rises through the Earth's crust onto the surface. Magma chambers within the crust are created by localized melting and upward migration of partially molten crust and mantle rock. This melting requires special conditions, such as the ascent through convection of solid mantle rock beneath oceanic spreading ridges, the addition of seawater at subduction zones, or the presence of rising mantle plumes beneath hotspot volcanoes. Magma travels from the chamber up to the Earth's surface either through fractures in the crust or by literally melting a path through the surrounding rock. A volcano is both the vent at the Earth's surface through which volcanic materials erupt and the edifice created by their accumulation around the vent, as well as magma that erupts as lava. Volcanic products include gas, ash, and fragmented rocks. These can pour gently out onto the Earth's surface or be blasted through the atmosphere, to be spread globally by high-level winds. Volcanic material erupted at the Earth's surface varies according to the properties of the magma from which it is derived. Differences in chemical composition, gas content, and temperature all affect the way in which magmas erupt, and therefore the types of landforms and volcanoes they produce. Magmas that have high silica content and low temperature are very viscous and slow-moving. If they reach the surface with high gas content, their eruptions are highly explosive. If they lose their gas during ascent, they instead erupt as lava. Silica-rich lavas are thick, slow-moving block lavas that do not travel far from their source. They are associated with subduction at destructive plate margins and the assimilation of rock materials from continental crust. Basaltic lavas, including Pahoehoe and have low silica content and high temperatures. They are extremely fluid and can travel at high speeds up to 60 miles per hour, 100 kilometers per hour over great distances. They are associated with hotspot activity, such as that under Hawaii, as well as ocean floor spreading, where they produce pillow lavas. Volcanologists traditionally have recognized different styles of volcanic eruption, although these styles can often mark different phases in a single event. Strombolian eruptions are spasmodic and discrete explosive bursts, a few seconds long, which eject pyroclastic materials a relatively short distance into the air. High gas pressures fragment magma within the vent, but with frequent release, no sustained eruption cloud develops. Vulcanian eruptions are more violent, producing highly fragmented ash and rock. Eruptive columns can rise 6 to 12 miles, 10 to 20 kilometers, with ash spread over huge areas. Plinian eruptions expel large columns of pyroclasts and gas at high velocities, hundreds of yards per second, up to 30 miles, 45 kilometers, well into the stratosphere. Collapse of such columns can produce deadly pyroclastic flows, containing gas and pyroclasts of all sizes, traveling at high speeds and covering large distances. In contrast, Hawaiian eruptions produce copious low-viscosity lavas, associated with shield volcanoes. Where similar eruptions occur in shallow water, they are known as Surtsian. These eruptions can be highly explosive as a result of water invading the vent, expanding as it turns to steam, and fragmenting the magma to blast out glassy fragments. Many different types of volcanic material can be preserved in the Earth's rock record, and their analysis reveals a great deal about the nature of past volcanism. Although lavas are the best-known volcanic products and can vary considerably in composition, texture, and volume, fragmented volcanic rock materials, or pyroclasts, are in many ways the most interesting and have the greatest impact on life. They are produced by explosive eruptions of parent magmas that evolve into gaseous columns containing fragmented rock, minerals, and glassy shards. Deposits are classified by particle size. The smallest, usually called ash, is fine enough to stay aloft for days or weeks and can be distributed globally by high-altitude winds. Fragments can also combine with hot gases to produce glowing pyroclastic flows rolling across landscapes at up to 125 miles per hour, 200 kilometers per hour. At the other end of the scale, some volcanoes have been known to eject rock fragments bigger than a house up to several miles. Tephra is a collective term for fragments of volcanic rock and lava of all sizes that are blasted into the air. Heavily glaciated, with an ice-filled summit crater complex, Mount Rainier is the highest peak in the Cascade Range. The collapse of a much larger structure about 5,700 years ago produced great lahars that flowed more than 60 miles, 100 kilometers, to Puget Sound. The present-day cone, capped by overlapping craters, formed during a major explosive eruption about 2,200 years ago. The strikingly symmetrical cone of Mount St. Helens had long been admired as North America's Mount Fuji. However, on May 18, 1980, in one of the world's best documented eruptions, the top 4,600 feet, 1,400 meters, of the volcano was destroyed, leaving a horseshoe-shaped caldera. Magma intrusion caused the north flank to bulge outward and then collapse in a debris avalanche, uncorking an explosive eruption. The avalanche traveled about 16 miles, 25 kilometers, at speeds of up to 250 feet, 75 meters, per second, filling a valley with debris up to 640 feet, 195 meters, deep. An explosive blast of hot gases and magma traveled ahead of the debris avalanche, flattening more than 10 million trees over about 230 square miles, 600 square kilometers. Later, collapse at the base of the eruptive column produced numerous pyroclastic flows, at temperatures of about 1,300 degrees Fahrenheit, 700 degrees Celsius. Formed in 9 eruptive phases beginning 50,000 to 40,000 years ago, Mount St. Helens has been the most active volcano in the Cascade Range during the Holocene epoch, the last 10,000 years. The modern volcano has been constructed within the last 2,500 years as basaltic, andesitic, and dacitic magma erupted from both summit and flank vents. Etna is Europe's highest volcano, and has been almost continuously active since observations were first recorded, about 2,500 years ago. About 2.5 million years old, Etna probably originates from a mantle hotspot. The volcano has a tall cone with a base circumference of about 95 miles, 150 kilometers, and a surface area of about 620 square miles, 1,600 square kilometers. Etna's most prominent feature is the Valle del Bove, a 6-mile, 10 kilometers, wide horseshoe-shaped caldera open to the southeast. The summit is a complex structure of old and new craters, and currently there are 4 active craters. The sides of the volcano are scored by deep fissures that radiate from the summit. Up to 200 small ash cones are present on its flanks, with 3 larger cones near the summit. Etna produces basaltic lava that has low viscosity, and lava flows extend to the foot of the volcano on all sides, reaching the sea over a broad area on the southeast flank. The summit craters are in a permanent state of low-level activity, with lava fountains erupting and phreatic explosions. Although Etna has not been considered an especially explosive volcano, at times it can be spectacular. Etna's largest and most famous eruption, in 1669, lasted 122 days. Earthquakes opened an 8-mile, 12 kilometers, long fissure and outpourings of basaltic lavas rapidly overwhelmed nearby villages. The 1986 summit eruption produced lava fountains that jetted up to 1 mile, 1.6 kilometers, above the crater, and a column of ash and gas that rose 6 miles, 10 kilometers, into the atmosphere. More recently, eruptions in both 2001 and 2002 again brought Etna to the world's attention. Kilauea is the most active of the overlapping volcanoes that have built the island of Hawaii over the million years. With its massive low-angle slope profile and wide caldera, it is a typical shield volcano built up by frequent summit and flank basaltic lava flows interspersed with lava lake activity within the crater. About 90% of Kilauea's surface is formed by lava that is less than 1,100 years old. Since 1983, during a period of constant eruption, flows have covered over 40 square miles, 100 square kilometers, and destroyed up to 200 houses. Most of Kilauea is hidden beneath the sea. Hawaii is part of a chain of volcanic islands built up over the past 75 million years as the Pacific Plate passed over a mantle hotspot at a rate of about 32 centimeters per year. Japan's highest mountain, Mount Fuji, is a symbol of its homeland, and one of a chain of volcanoes along the western margin of the Pacific Ocean. It is a typical stratovolcano, with a steep-sided, symmetrical cone built up of layers of lava flows alternating with ash and other debris. Growth of the present volcano began 11,000 years ago on top of older volcanic remnants. Within 3,000 years, about 80% of the current bulk of the volcano had built up in outpourings of basaltic lava. During the long eruptive history that followed, lava flows and violent eruptions were emitted from the 2,300 feet, 700 meters, wide summit crater and numerous flank vents, building up more than 100 cones. Some of these lava flows blocked river drainage to the north, forming the Fuji Five Lakes area, which has become a popular tourist area. The last eruption in 1707 was the largest in historical times. It formed a large new crater on the east flank and deposited ash on Tokyo, over 55 miles, 90 kilometers, to the northeast. Africa's highest mountain, Kilimanjaro, is one of several volcanoes whose formation is associated with the eastern part of the East African Rift. An elongated complex cone, more than 30 miles, 50 kilometers, long, it consists of 3 volcanoes. The mountain was mainly constructed during the Pleistocene epoch, 1.8 million 10,000 years ago, but includes a group of nested summit craters that are apparently younger. Kibo is the highest and central cone and erupted between the other 2 Shira and Moenzi. It is topped by a glacier-covered subsidence caldera with an inner crater called the Ash Pit. The 24-mile, 3.5 kilometers, wide caldera gives the summit its broad, elongated profile. Most of the 250 flanking lava and cinder cones are less than 330 feet, 100 meters, high. Recent volcanic activity has been mostly confined to fumaroles around Kibo's crater, lying just 200 miles, 320 kilometers, north of the equator and yet high enough to be snow-capped. Kilimanjaro supports a unique ecosystem adapted to a wide range in temperature. Vesuvius is a frequently active volcano overlooking the Bay of Naples. Its cone, with a base circumference of about 45 miles, 70 kilometers, sits within the caldera of an older volcano, Monte Somma, that formed about 17,000 years ago. Vesuvius is best known for its Plinian eruptions, such as the one in AD 79 that destroyed Pompeii and Herculaneum. Since the modern cone formed, there have been 8 major eruptions, accompanied by large pyroclastic flows and surges, and high eruptive columns capable of carrying pumice, ash, and bombs dozens of miles into the air. In 1631, during the largest eruption since AD 79, pyroclastic flows reached as far as the sea. More recently, Vesuvius erupted in 1906 and 1944, causing fatalities on both occasions. Today, about 3 million people live within the eruptive range of Vesuvius, and evacuation plans are in place.